I will be giving this presentation today for about an hour, and you're very welcome to leave your comments or questions in the chat box displayed on the bottom left of your screen. There will be some time in the end to reply your questions, so please feel free to make any comments or any statement you would like to. Briefly about this webinar. The reason for organizing this webinar is to raise awareness on sustainability issues related to the agri-food sector, and also to demonstrate some of the possibilities of the environmental impact methods like life cycle assessment via some practical examples that I will give during this presentation. So it's a pretty introductory webinar, more as a kickoff for the webinars to follow. So many of you might be familiar with some concepts, but hopefully you will find it interesting and you will have learned something new by the end of this presentation. So firstly, I would like to say a few words about the Blonk Consultants team and myself. Later on, we will take a quiz where you are asked to reply 3 multiple choice questions. So I have also created polls that I will share with you during this presentation, and then you can online submit your answer. Then after that, I will move on to the life cycle assessment methodology. This is how this we call it LCA, and it's an analytical method of assessing the environmental impact of products. So I will also discuss some implementations of LCA, like the recent developments on the European PEF project and other implementations. And we will wrap up with a session on why to use LCA in the first place and what are the limitations of LCA. And I will conclude with the follow-up events after this webinar. So this is me. My name is Elena Koukouna. A few words about me. I did my bachelor studies in industrial management and supply chain in Greece, and I moved to the Netherlands in 2011 to do my master studies here in industrial ecology. That was a joint program between Leiden University and TU Delft. During my graduation project, I collaborated with a European Yatromed project. That was a project on the evaluation of Yatrov as an energy crop. And during this project, I had the chance to work with an interdisciplinary group of scientists and conduct a life cycle assessment. And for the last 2 years, I'm working for Blonk Consultants. So during this period of time at Blonk, I have worked on several projects. I have chosen four projects to highlight here, so for you to get an idea of what I'm doing and who I am. I have been working on environmental data analysis and verification for Heineken, who is our customer for the quite some last years. And I have been also working on the supporting studies for the European beer PEF pilot on modeling the life cycle of LCA. And lately I have been involved on the Agri-footprint database, which is the food LCA database developed by Blonk Consultants. And we are currently preparing for the new release somewhere in the beginning of next year. So within this project, I have been working on pesticide production and fertilizer use for several crops. And finally, I worked on the vegetable and fruit calendar for Milia Central. Milia Central is an initiative of the Ministry of the Environment here in the Netherlands, and it is an online tool which serves as a classification system of vegetables and fruits found in the Dutch retail. So basically, these vegetables and fruits are assigned a score from A to E based on their environmental performance. And what I've done basically is to assess their environmental performance by taking into account the cultivation, the transport, and the packaging. And except from my work, I like also to read, to travel, and sport. So that's about me. Blonk Consultants was founded in 1999. by Hans Blonk that you can see on the bottom right of your screen. He is the founder and director of this company, and we are a group of 10 sustainability consultants, and we are located in Gouda here in the Netherlands. Our vision as a company is to help for a society that has a more healthy and sustainable lifestyle. What we are doing as a consultancy, we have 3 main areas of expertise. LCA is one of our core activities, so we are conducting life cycle assessment studies for both companies and organizations to help them measure, compare, and improve their impact. And we also develop tools for companies and experts, as well as the LCA food database that I mentioned earlier to you, Agri-footprint database, that currently contains more than 3,000 products and processes. And it's available via the CIMA Pro software, which is used by something like 2,000 users. We are also active on sustainable nutrition assessment, and this is another core topic of our work. So we are working on projects that integrate both environmental impact and healthy diets, and I will give an example on that later on. And finally, we are assessing the sustainability performance and doing the sustainability reporting for companies, conducting data verification and materiality analysis. And we are also assisting on setting benchmarks and helping them to implement efficient solutions. So at this point, let me see. Okay, so yeah, at this point it's time to take a quiz. So I have prepared 3 multiple choice questions for you. So I will publish the poll, and you're very welcome to submit your answer. I will give you a few seconds to think over it. So let me see how that works. So you should be able now to see the first question. So how would you rank the following beverages from highest to lowest carbon footprint impact from farm to consumer? So you have a list of beverages here, and I'm asking you to assess them from the highest to lowest carbon footprint impact. And now you should be able to see the question on your screen. So it's very interesting to see your answers. Okay, a few more seconds. I'm gonna close the poll now. Yes. So most of you voted for answer C. So soya bean has a higher carbon footprint than cola, than chocolate milk, and so forth. Now we'll display the right answer. So the right answer is A. A few people got that. Yeah, as you see, the dairy-based beverages, for the dairy-based beverages, the dairy farm is an important source of emissions, contributing to carbon footprint. So you see that the choco milk and the cappuccino have a high contribution due to the milk production, which is a blue bar. Choco milk has the highest carbon footprint due to milk production, but also to beverage production and other ingredients. So in this case, the cacao beans cultivation. Red wine is the second performing high, and this is due to the alcoholic fermentation in winemaking, but also due to packaging, because wine is packed in glass bottles, and glass has generally quite a high carbon footprint impact in LCAs. Fresh orange juice, which is the orange juice squeezed at home, has also relatively high impact due to the cultivation of oranges. And you can see also that the retail, which is the purple bar, is also higher compared to the other beverages, and this is basically because you need quite some oranges to take in the end 1 kilogram of orange juice. So more oranges need to be traveled from the retail to your house, basically. And the cola, soya milk, and coffee have a relatively low impact compared to the other beverages. And again, you can see that the packaging is quite contributing to the cola. And for soya milk and coffee, cultivation are the main contributors of carbon dioxide emissions. So let's move on to the next quiz. You did quite well, don't worry. Now, I think it's a little bit slow. Oh yeah, here we go. So, how much agricultural area for soya production in South America do these products require? Here you see three different products: milk, pangasius, and beef. All these three products, they use soya as a feed ingredient. So the question here is how much agricultural land dedicated to soya production in South America do these products require, from highest to lowest square meters annually per kilogram of product. I will publish the poll. That one. A few more seconds to close the poll. Okay. So I hope you had time to answer this question. Most of you picked answer B, so beef requires more land and milk than pangasius. The right answer is C, and here you can see the results. Many people tend to think that milk has the highest agricultural land occupation, but actually you can see with a gray color the contribution of with a gray color you can see the share of land for soya production in South America. So for pangasius, that's 5.39 square meters. For beef, it's 4.1 square meters, and for milk is 0.14 square meters. Maybe I can use the spotlight. So this is the figure for pangasius in square meters, for beef, and for milk. And on the bottom of your screen, you can also see the total land dedicated for the production of each of this product. This one, okay. So let's move on to the last quiz. So a plant pot manufacturer produces plant pots from polypropylene filled with limestone. He had asked Blonk Consultants to carry out a study on whether it's a nice idea to change his production line or shift to a different material for the plant pots. So should he shift to cocoa peat and wood fiber pods? Should he stay with polypropylene, or should he shift to polylactic acid? And polylactic acid is a bioplastic. So what you would advise him? Oh. A few more seconds left. So I will now close the poll. Yeah, so there was a strong competition between cocoa peat wood fiber pods and polylactic acid pods. The result of this study was to stay with polypropylene, and I was expecting that you wouldn't guess that, and it might be even disappointing to some people, but basically it was more environmental friendly, looking at several impact categories, to stay with polypropylene. So basically, this was a study carried out in 2013, and it was based on company-specific data to a great extent. So the raw materials for plant pods, energy consumption, and secondary and tertiary packaging material was based on company-specific data, and it was a study that was externally reviewed by a panel of reviewers. So we saw that a polypropylene was the best performing system in that case. I have used here a heat map. So the greener, the better, basically. So you can see the three different materials for two different end-of-life scenarios, or end-of-life stands for waste treatment scenarios. So let me highlight this. So here you see the polypropylene with incineration with energy recovery, polypropylene with recycling, polylactic acid again with incineration and energy recovery, polylactic acid with composting, and the peat wood pods with incineration and energy recovery and composting. So for the polypropylene plant pods with recycling, we get the lowest impact on climate change. So you see it's pretty green. And this finding indicates the importance of supporting and promoting post-consumer recycling. Now, as the energy content of PLA is lower than the polypropylene, this has a subsequent impact on the recovery from incineration, and that's why polylactic acid incineration scores higher than polypropylene with incineration. I know you cannot see it here in absolute figures, but I skipped out the numbers for simplification. We also see that in terms of acidification and eutrophication, the polypropylene product system scores better, and this is due to the avoided mining of fossil resources due to energy recovered during incineration. The land occupation is higher for the polylactic acid and peat wood pods, as expected, because it's related to the cultivation of corn for polylactic acid and coconut for the peat wood pods. And water depletion for the bio-based material is again related to irrigation water, while polypropylene pods do not require a lot of water. And as for the fossil depletion, it's basically the same principle as for climate change. So due to the avoided emissions during incinerations, the polypropylene system performs better than the rest of the scenarios. So that was a little bit about this case study. So now I would like to move on why it is important to determine the footprint of products anyway, and how you can do that. So, well, I believe it goes without saying that economic growth and environmental stress on Earth should be decoupled. Due to resource depletion, there is a need for novel products in the market, like novel foods, alternative protein sources, and energy efficient solutions. At the same time, the companies need to reduce their costs by applying efficient solutions. There is also the need to raise public awareness and involvement in hot issues like deforestation, sustainable fishing, and sustainable nutrition. And there is overall the need to adopt a healthy lifestyle. So environmental assessments can actually support those needs of the contemporary society. And there are actually a lot of methodological tools that allow you to measure those impacts, like life cycle assessment, environmental input and output analysis, material flow analysis, carbon and water footprinting, ecological footprinting, ecosystem service valuation, among others. And I will not explain each one of those. We will focus on the life cycle assessment, which is a holistic approach, and it captures the whole supply chain and is a multi-impact assessment method. So considering the whole supply chain of agri-food sector, excuse me, I have a delay with my screen. Okay, now it works. So considering the whole supply chain of agri-food sector, we encounter different life stages. So we need the extraction of raw materials and resources, agriculture and husbandry, processing of products into marketable products, distribution of goods, the consumption phase, and finally the waste disposal. And this is what we call the life cycle. So the life cycle assessment is a standardized method from ISO 40040 and ISO 40044. The framework comprises of 4 methodological steps: the goal and scope definition, inventory analysis, impact assessment, and interpretation. Some examples of direct application of LCA tool is product development and improvement. So LCA is being used in R&D and eco-design, for example. Is also used for strategic planning, for business-to-business communication, and for decision making within companies. It's also used for policy making and marketing. And by marketing, I don't mean greenwashing, but more communicating impacts with stakeholders and consumers. And you can also use LCA towards consumer tools, like, for example, phone applications, etc. So a bit on the history of LCA. Back in 1969 is the first milestone when Coca-Cola quantifies for the first time the environmental impact of its packaging. And this study was carried out to examine the business decision on switching from glass bottle to plastic bottle. A few years later, the US EPA creates an approach known as the resource and environmental profile analysis. During the 80s, there is a growing interest on sustainability and environmental related issues, but there is no LCA software or other kind of tool to support the study. But in the 90s, there is a remarkable growth of scientific activities worldwide. So there's the release of the first LCA software like CIMAPRO, as well as the release of databases like EcoEvent and journals like the International Journal of LCA. In 1992, there is the first food LCA by Unilever on margarines. And in 1996, the publication of Environmental Management, ISO 14001. In 2006, we have the publication Livestock's Long Shadow is the name of the document published by FAO, and this is a document on the assessment of the significant impacts of the livestock sector on the environment in order to raise attention to environmental issues. And the final, the most recent development is the product environmental footprint, the PEF project that we will discuss later on. So this is an overview of how the publications on food LCAs have been performing the last decades. So you can see there is an increasing publication rate. And now I would like to give you an example on the case of pork product system, and through this example we will go through its methodological step of LCA. So looking at the goal and scope definition, on a husbandry level, we have the sow, the female pig that gives birth to something like 27 piglets on a year. Those pigs are raised to fattening pigs before they end up to the slaughterhouse. Yes. And at the slaughterhouse level, there are products for human consumption and non-human consumptions like meat and other byproducts such as pig hides, organs, hooves, bones, and blood. All these products and byproducts are further processed into useful marketable products and or they are safely disposed via waste treatment. All those marketable products will go through the retail all the way to the consumption phase. And so this is a typical product system of a pig from farm to plate, as we call it. And this is how you would define your system boundaries in the goal and scope definition. So the system boundaries are always depend on your goal. So somebody could decide also to just focus on the farm level or on the slaughterhouse. But this is just an example of a full LCA. And at this point, I would like to briefly mention the multifunctionality within LCA. So what we call multifunctional processes are the processes that are producing more than one products. In that case, the husbandry and the slaughterhouse is, for example, a multifunctional process. So at the farm level, not only piglets are produced, but also the sow will eventually end up to the slaughterhouse. So there is the need to allocate environmental impacts to both the piglets and the sow. And also at the slaughterhouse level, we have fresh meat production and other byproducts production. And again, the environmental impact needs to be allocated in all those products and byproducts. And we use several methods to do that. One method is the economic allocation method, based on which the environmental impacts are assessed based on the economic value of the products, or the energy allocation method, based on which the environmental impacts are allocated based on the energy content of the products, and so on. So that was briefly to give you an idea of some of the complexities of the LCA. I will move on to the second methodological step, which is inventory analysis. So assuming that you have a product system from farm to plate, you need to collect data and basically inventory all your data and model your system. So some of the data that you might need is the feed production. So you need the composition of your feed and data on the cultivation of the feed, water consumption, manure management on a farm level, energy and fuel consumption along the whole life cycle, data on transportation, data on waste treatment, packaging and retail, etc. An example of an impact assessment method. So in this case, I demonstrate the result of pig feed at the farm level. So this is a process taken from Agri-footprint database. I have grouped some some feed ingredients into a larger group for simplification. So here you can see, where is my hot? I'm trying to find my spotlight. Give me a second, because it's pretty handy. Oh, here it is. Okay. So here, for example, you see that the contribution of the wheat grain and barley grain and the contribution of palm oil and soya bean into the carbon footprint of 1 kilogram of pig feed production. So that's an example of an impact assessment. You could also choose to make an extended impact assessment from farm to plate. So in this case, you can check several impact categories: climate change, freshwater eutrophication, fossil depletion, and water depletion. And again, you can see the contribution of each life stage displayed on the right of your screen. So, for example, we can see that the pig feed has a high contribution on the eutrophication of freshwater, and this is mainly due to the fertilization during cultivation. Similarly, we can see that for fossil depletion, the pig feed and the packaging has also high contribution, and this is an example of how your impact assessment would look like. And now moving on to the interpretation methodological step. You have again different choices. I'm just demonstrating some examples for you to get a feel of what is every methodological step basically. So this is an example of different allocation methods. So economic allocation, energy allocation, and mass allocation. So in this case, you can see that by applying economic allocation, the carbon dioxide emissions of your system are always higher than by applying an energy allocation method, which is the blue bar. So it's interesting to see how different allocations basically affect the performance of your system in that case. Another example of interpretation is displayed here. So this is an overview of a pig fresh meat at the slaughterhouse. This graph is modeled in CIMAPRO, which is an LCA software. So here basically you can do a contribution analysis on climate change, and the red bars are indicating the hotspots along your life cycle. So in this case, you see again that the pig feed has a big impact on climate change along the whole along the system from farm to slaughterhouse. You can also make a contribution analysis on water depletion, for example, and then again with the red bars you can see what are the hotspots of your system. So in this case, drinking water for pig and also for the hygienic of pigs is the biggest contributor of water depletion. And that's simply to give you a feel of what is happening in every methodological step of LCA. So now we'll move on to the latest developments in the LCA world. As I mentioned earlier, the PEF project, which stands for Product Environmental Footprint. So how the PEF project came to be. The idea behind it is that business wishes to perform better by becoming greener. So to judge companies' green credentials, the entire environmental performance needs to be evaluated in every stage of the supply chain. And that's complicated for the companies because they need to carry a lot of assessments, and it's a very time-consuming and also costly process. So the European Union has designed two methods, the PEF and the Product Environmental Footprint and the Organization Environmental Footprint, in order to develop a harmonized approach of assessing the environmental impact of the industry. And on the same time, communication to consumers will be also facilitated by simplifying the labeling scheme. which is not clear right now to most of the people. So here on the table you can see the 11 food pilots and 40 non-food pilots running within the PEF project, for which extended LCAs were carried out and the best application way was tested. You can see in bold the PEF pilots that Blonk Consultants have been working on, so beer, feed, and meat. So the goal of the PEF project is to create a uniformity in the market and come up with a harmonized, standardized way for companies to evaluate their performance. In the link that I have included on the bottom of this slide, you can visit all PEF pilots, and by making an account as a stakeholder, you will be able to keep track of every pilot that is of interest to you. So here you can see the link. Okay. The plan was that this project would be finalized in the end of 2016, so somewhere by now, but it will be extended for next year and it will be finalized somewhere in the end of 2017. The completion and remodeling of the final PEF-CRs is still pending. The PEF-CRs are the PEF category rules for the different pilots, and the testing of communication vehicles is still on go. Excuse me. Now, moving on to another example of LCA application and recent development in the field of sustainable nutrition is the menu for tomorrow. The Dutch environmental organization Natuur en Milieu asked Blonk Consultants to investigate what a healthy and sustainable diet would be for the Netherlands. So we came up with a diet that was environmentally friendly, in line with health standards, minding consumers' behavior, and affordable. And by saying minding consumers' behavior, I mean that we excluded scenarios of veganism, for example, because we are aware that people will not be willing to drastically change their diets. And so by applying this diet, the greenhouse gas emissions, fossil energy, and land use would have decreased by 2030. You can see the absolute figures here. So these are the values of 2010 and the foreseen values for 2030 by implementing this diet, and the price on a daily basis would remain relatively the same. Again, at the bottom of the slide, I have included the reference, so you can access this. This publication is available in Dutch, but there is also a summary available in English, and you can also find there the other relative diet. If you are further interested in healthy diets, you can also visit our tool portal and try the Optimize Your Diet game that we have developed. This is an overview of the tool Optimize Your Diet. Personally, I find it very interesting, so that's why I choose to show it to you today. The tool looks like that. So on the bottom of the bottom, you can see different food categories. Let me use my spotlight again. So on the bottom, you can see the food categories where you are expected to add the amount in grams consumed per day. So here you can add your values in grams per day. And then you will see the graphs here above dynamically changing every time you modify the inputs on a daily basis. So the first chart pie, called nutrients, shows the contribution of different food groups to the different nutrients selected on this field. So here you have different nutrients, fibers, calcium, iron, etc. And on the chart pie below, you can see the contribution of each food product to those nutrients. The second graph shows your nutritional boundaries. So basically here, all the nutrients need to be balanced in the middle, so that you have neither a surplus nor a deficit of a nutrient, and then this would be a healthy diet. And finally, on the last graph, you can see how your carbon footprint is dynamically changing when you are changing your diet. And you can also submit your diet with this button here on the bottom. But in order for you to be able to submit your diet, this middle graph should be balanced to 0. So you can only submit a healthy diet. And you can always come back to your latest results and try to optimize your diet again. So if you like this challenge, you can try to access the tool on this link here below and submit your diet. I think it's pretty interesting to check it out. So moving on to the next slide. Yeah, this is a wrap-up session. So why LCA is why to use LCA, why LCA is a good methodology to use. So LCA is an ISO standardized method, and there is a general consensus on its applicability. It allows the identification of hotspots and inefficiencies along the life cycle of a product. It serves as an input for R&D, for product development, eco-design, as for example in food engineering. It can be used to business and business to consumer communication. There is a high level of acceptance and understanding, especially among companies. And governments and companies are increasingly asking for the environmental performance of the products they buy in new contracts. So environmental performance is an increasingly new clause in contracts. Is an overall satisfying tool in decision making within a company, so it can help companies to decide on the investment of a new packaging machine or in the shift to a new product, and overall in different decision making processes. And finally, LCA paths are being used for environmental product declaration and other standardization schemes. Of course, there are some limitations on the applicability of LCA. So the availability and quality of data is very often poor. So when you're making an LCA, you should be very aware of this limitation and make sure that the quality is good enough. And if not, you should be always reporting this sufficiently and be explicit to all the assumptions that you're using as an LCA practitioner. Moreover, there are only known and quantifiable environmental impacts are considered in LCA. For example, there are no methods for antibiotic resistance at husbandry level. The ecosystem services like biodiversity loss or biodiversity enrichment is not really taken into account by LCA. There is no robust method on how to do that. And also case-specific problems like the plastic soup in North Pacific, for example, is not directed by methodologies like LCA. Another limitation is that there is no scientific basis to aggregate LCA results into a single score. Of course, there are methods on aggregating results to a single score, but they are not very scientifically robust. Moreover, the complexity of LCA is very often pretty difficult to communicate, especially to consumers. And yeah, that's a challenge that every LCA practitioner has to face. So it's important to be, again, explicit of all methodological choices and assumptions when you're carrying out a study. And finally, the misuse of LCA to support environmental claims is something that has occurred a lot of times in the history of LCA. So basically, we have seen comparative assertions based on different underlying methods, or the so-called black box LCAs. So where a complex LCA is just very quickly done, quick and dirty, as we call it. So these limitations we should be aware of when carrying out a study, and as a practitioner you should be always cautious to avoid these barriers, basically. So finishing up, there are different software and databases and tools related to the life cycle assessment methodology. Professional softwares are the CIMA-Pro, Gabi, and OpenLCA. Databases like Agri-food can be used to support life cycle assessment studies, and tools like the direct land use change assessment tool that you can find on Blonk Consultants website is built on the IPCC methodology, as well as the Optimize Your Diet tool that I showed you earlier. So the upcoming events, we just finalized the first webinar. There will be another 3 webinars following. The second webinar will be on advanced topics in LCA somewhere in February. And webinar 3 on agricultural land use change and webinar 4 on sustainable diets will take place somewhere in the end of March, beginning of April, I believe. And we have already arranged an LCA training for the 15th, 16th, and 17th of February 2017. So you are very welcome to join this LCA training if you're interested. And you can find all information on our website on the link that I have included here below. And if you registered, you can use this discount code to get a 10% discount. So you're welcome to check it out.